by the military and also by the civilian. Okay, so this is what the IRNSS is. Now let us discuss the Indian satellite system. Now Indian space program is actually the wider one. It is the umbrella project, and within the umbrella project we have the satellite system, and you find that ISRO is actually responsible for actually manufacturing, that is producing and sending the satellites into space. Now ISRO was started in 1960, and from 1960 the main purpose or goal of ISRO was to use space for peaceful purposes. Now ISRO is not in a mood to actually create things that would actually have a military purpose. Our ISRO's purpose is only to make instruments or make satellites that are used for peaceful purposes. Okay, so our main objective is using space for peaceful purpose. Now the Indian satellite system, when we talk about Indian satellite system, it's actually divided into two systems. One is known as the INSAT, the other one is known as the IRS. Now INSAT stands for Indian National Satellite System, and IRS stands for Indian Remote Sensing Satellite System. So on the one hand you have INSAT satellites, on the other hand you have the remote sensing satellites. Okay, now so this is what the INSAT system is and the IRS system is. Now the main objective of ISRO is peaceful use of space. Okay, now this INSAT and remote sensing, where do we use? INSAT satellites are actually all geostationary satellites. Now INSAT satellites, these are all geostationary satellites, and they are used for the television broadcasting and other communication purposes. Okay, so most of the communication purposes are actually served by these INSAT satellites. So they are used for communication, weather forecasting, remote sensing, disaster management, and also tele-education, etc. So these satellites could also be used for tele-education, etc. Now if if the government wants to start a channel, then it of course has to request the ISRO to provide the particular frequency for this particular channel. Okay, now ISRO actually provides these frequencies for the various channels. So most of the UGC and Indira Gandhi Open University, most of them have got their own channels, and these channels now recently in this budget, I think in the last budget, the government was actually starting a Kisan TV. So therefore Kisan TV is completely dedicated to the farmers of India. Now this TV, so this channel would be broadcasting information relating to agriculture. Now this Kisan TV, now who would be providing the frequency or that particular channel for this TV? That particular thing has to be done by ISRO itself. Okay, so ISRO, most of the work that ISRO is doing is on peaceful purposes only. Now INSAT system brought a revolution in TV and radio broadcasting. In the 80s, INSAT system brought a revolution when it comes to radio and TV broadcasting. Now Kalpana 1 is a satellite that is exclusively meteorological satellite. Now most of the meteorological satellites are also geostationary satellites. You have to remember that. Okay, now 24 satellites have been launched until now. That means up to August 24 satellites have been launched, and I think in the month of August itself there is also a satellite called as GSAT 16 that would be launched. Okay, now 10 out of them are operational. Out of these 24 satellites, now 10 satellites are in operation. Now INSAT system was actually commissioned with the launch of INSAT 1B. Actually INSAT 1A failed, and later on INSAT 1B was launched, and the INSAT system was actually commissioned after INSAT 1B. Now IRS system. So INSAT system is used for communication and other communication, broadcasting, and also disaster management and other various purposes, education and all. Now what do you mean by IRS system? So IRS system, IRS stands for Indian Remote Sensing. So what do you mean by remote sensing? Now remote sensing satellites are actually used for various civilian purposes. Now India stands first when it comes to the operation of the remote sensing satellites. India has got the largest number of remote sensing satellites of any other country. India has the largest number of remote sensing satellites. It has 12 operational satellites. So it is the biggest satellite system in the used for civilian purpose. It is the biggest satellite system used for civilian purpose. So we have 12 operational satellites. Now they are placed in the sun synchronous orbit. Now they are placed in sun synchronous orbit. Now what do you mean by sun synchronous orbit? Now an orbit which precesses once a year. Normally what happens is the orbit will not actually precess. The orbit will actually be a stable orbit there, but this sun synchronous orbit would be actually precessing for every 1 year. Because of this precessional motion, you find that the illuminating angle is such that when the satellite actually completes one revolution and comes to a point, the illumination will look the same. That means if this is the surface of Earth and if this is the orbit, then if this point, now if at this point I want to do my work, then the satellite will find that the illumination is constant. Now the satellite completes one revolution, again it comes here tomorrow morning, then it will find that the illumination is same. So in case of sun synchronous orbits, you find that the illumination angle is most of the time constant. So therefore you could take pictures continuously for an year with the same intensity, okay, with the same intensity. That means if I want to take pictures using visible light or infrared, then I have to use these remote sensing satellites that are placed in the sun synchronous orbit, okay. So this is what the illuminating angle. So the surface illuminating angle will near be same every time the satellite is overhead. So every time when the satellite is over your head, you find that the illuminating angle is same. So therefore the satellite could take pictures accurately using either visible light or else infrared, okay. Now it uses either visible or infrared. Now spy satellites and remote sensing satellites, they are all placed in the sun synchronous orbits. Now let us come to an important event that actually happened in 2014, which is known as MOM, or Mars Orbiter Mission. It is otherwise known as Mangalyaan. Now this Mars Orbiter mission actually turned ISRO into a global satellite, into a global space organization, okay. So we were normally a regional organization, but once ISRO actually placed an orbiter in the orbit of Mars, then it actually turned from a local space organization to a global organization. Now what are the important points that we need to discuss when it comes to MOM? Now MOM is India's first interplanetary mission. Now normally Chandrayaan was not an interplanetary mission, okay. It was just a normal mission where you wanted to place a man-made object onto the orbit of the moon. So in the Chandrayaan we just went to moon, but Mangalyaan is different. We are not moving to any satellite, we are actually moving to another planet. We are actually trying to move to another planet. So it was the first interplanetary mission that India actually undertook. Now it is the only fourth country to have done so. So in the world it is the only fourth country to have done so. US, European Union, Russia have already done it, and India is the fourth country to have done it, and India is the first country to have done it in the first attempt itself. So India is the first country to have placed an orbiter in the Mars orbit successfully for the first time. Now India is the first country to have done it in the first attempt itself successfully. Now normally Japan has tried it last year, China has tried it last year, but they have actually failed. Now India had tried it only once, and it actually succeeded at doing it, okay. So that is what, so in the maiden attempt we have done it. So we have done it successfully in the maiden attempt itself. Now what are the objectives? Now why do we need to send these missions? Because normally around 450 crores was spent on this mission. So 450 crores is actually not a big amount when it comes to India, but normally there are critics saying that we could have used that amount to feed the poor of this country, but there are some scientific reasons that we need to do it, okay. So what are the primary objectives of doing this? What are the primary objective and what are the secondary objective? Now the primary objective is one thing, this is the important thing. Now the primary objective is to test the technologies needed to design, plan and manage the operations of a interplanetary mission. So India wants to move to the outer space. India wants to send its orbiters to moon. India wants to send its orbiters to Mars and to other planets. So once we want to colonize any other planet or any other satellite, then we need to have this capability to send a human being over there. So if I want to send a human being over there, then I need to first test my technology. So this was the way ISRO was testing its design, plan and design and planning and how to manage the operations of an interplanetary mission. So if I want to further move on beyond Mars or any other planet, so therefore I need to test my technology, I need to test my plan, I need to manage my operations. So this is the primary objective of the MOM. So this is what ISRO was actually trying to do. Now what is the secondary objective? Now the secondary objective is to study the morphology and mineralogy of the Martian atmosphere. Now once the orbiter is placed in the orbit of the Mars, then of course it has to do something. It cannot stay there ideally. So therefore what they are trying to study is they are trying to study the morphology and also the mineralogy of the Martian atmosphere and also the surface of the Mars. Okay, now there are 5 instruments on board. And I have given those 5 instruments a layman: alpha spectrophotometer, methane sensor for Mars, Mars color camera, thermal infrared imaging spectrometer and Mars exospheric neural composition analyzer. And out of this 5, one sensor or one instrument is actually of importance, and that is MSM, methane sensor for Mars. Now why is methane so important? Now you find that methane is actually hydrocarbon. Now methane is actually the major component of natural gas, and you find that natural gas is a component of petroleum, and petroleum is actually a fossil fuel. So once if you have a large amount of methane, then it is clear that there was once a life that has really produced this methane. So petroleum is actually divided into crude oil and natural gas, and major component of natural gas is methane. So therefore if you find methane, then it is clear that there was once life, and because of the decomposition of that life, you get the methane gases. So therefore if methane is found on the surface or below the surface of Mars, then it is clear that there has to be some life on Mars. Okay, so therefore methane sensor is very important. Of course we do not have any data to show that there actually exists methane on the surface of or below the surface of Mars. So these are the 5 sensors that we need to use. Now next comes the launching vehicles. Now normally you find that it is all right to say that you place a satellite in a particular orbit, then the satellite would be giving you certain information, but how do you do it? How do you place a satellite in a particular orbit? So therefore you need a vehicle to place the satellite in a particular orbit. Okay, now what are the so what is a launch vehicle? Launch vehicle is nothing but a rocket. It is nothing but a rocket used to launch satellites in a particular orbit. This is what the satellite launch vehicle is. Now the launch vehicle works on what principle? Now the launch vehicle works on the Newton's third law. It is a simple Newton's third law. Now action is done by the gases that are moving downwards, and the reaction is done by the rocket which moves upwards. So this is a simple third law. What is the basic principle behind launch vehicles? Means it is Newton's third law. Now India, the first vehicle that India used was the satellite launch vehicle, SLV. Thereon we had the large SLV, and now at this point of time India has 2 launch vehicles. One is known as the Polar Satellite Launch Vehicle, the other one is known as the Geostationary Launch Vehicle. Okay, so these are the 2 launch vehicles that we are actually using. So one is the Polar Satellite Launch Vehicle, the other is the Geostationary Satellite Launch Vehicle. Now PSLV is actually the workhorse of ISRO. Now PSLV is very important. Now GSLV, you find that GSLV has not yet been successful in actually placing many satellites in the orbit, because GSLV has a cryogenic stage. Its third stage, it is a 3-stage rocket, and the third stage is actually a cryogenic stage, and that cryogenic stage is actually produced, that engine is actually produced, cryogenic engine is produced by India, and there is a problem with that particular stage. Okay, so the main workhorse of ISRO is PSLV. Now what do you mean by PSLV? PSLV is Polar Satellite Launch Vehicle. So I have already said it is a workhorse of ISRO. Now it is a 4-stage rocket. It is a 4-stage rocket. Now it can put remote sensing satellites in sun synchronous orbits. It can put the remote sensing satellites in sun synchronous orbit. It can also place orbits in a geostationary orbit. It can also place satellites in a geostationary orbit, but of course the weight of the satellite is very important. Its mass has to be very less. Its mass has to be less than 1500 kgs. Okay. And now, as of 10th July 2015, it has made 30 launches, and out of those 30, 28 have been successful. One was a complete failure, the other one was a partial failure. Okay. Now the latest is PSLV C28. The latest is the PSLV C28. Now this PSLV C28 is very important because it was the heaviest payload. Now PSLV C28 took the heaviest payload of 1440 kgs. It actually took 5 satellites which were weighing around 1440 kg. So it was the highest payload that PSLV actually took. So PSLV 28 is important because of the fact that PSLV C28 was the rocket that actually undertook the heaviest load that PSLV ever took. Okay, so this is what PSLV is. Now we also know that apart from PSLV, we also have GSLV. Now GSLV is actually a 3-stage rocket. It actually a 3-stage rocket. Now in GSLV we have Mark 1, we have Mark 2 and Mark 3. Okay, and you find that most of them are actually not at all working because of the 3rd stage. Now the third stage is a cryogenic stage. It's a cryogenic stage, and this cryogenic stage, the engine is produced by India. Normally the cryogenic engine was given by Russia, but now India is trying to place its own engine in the 3rd stage, and there is a problem with this engine. The engine is actually failing, and because of this failure the GSLV is not taking off. Okay, so once we have the capability, once we have the GSLV working, then you could place the satellites weighing 2500 kgs in a geosynchronous orbit or geostationary orbit. Now if I want to place a satellite in geosynchronous orbit, then I have to take that satellite to Ariane. Now I can't do it, so therefore there is another space agency known as Ariane that actually does it. So India cannot actually place satellites which weighing around 2500 kgs in a geostationary orbit. So INSAT satellites, most of the INSAT satellites are actually placed using the Ariane satellite. Now ISRO cannot do it by itself. If the weight is over 1500 kgs, then of course we have to use the Ariane space agency. We cannot do it by ourselves. Now once we have the GSLV, then we could place the satellites, our own satellites, which are weighing around 2500 kgs by our ISRO itself. Okay, so GSLV is very important. Now ISRO is now trying to concentrate on GSLV, and it is and most of the other projects they have left over, and they are concentrating on GSLV. So now it has to become the workhorse. PSLV, of course, it is doing a very good job, but it can only place satellites that are around 1500 kgs. Now if I want to place satellites that are over 1500 kgs, then I need GSLV. Okay, now ISRO is actually trying to do so. So these were some of the points that we needed to discuss in the second part of gravitation. So with this I want to conclude this concept of gravitation. Thank you.